In this video, we're looking at atoms, elements, compounds, and mixtures. We'll start off by focusing on the atom itself, commonly referred to as the building block of matter. Everything in the universe is made up of atoms, and there are over 100 different types of atom. If you were to cut any physical object in half, like an apple for example, and continue to cut each piece in half again and again, you would eventually end up with a piece of the apple that's so small it cannot be cut any further. This is an indivisible piece. And that is the original definition of the word atom. Indivisible. A unit so small, it makes up everything. However, we know now that atoms are in fact made of even smaller units, and we call these subatomic particles. There are three we need to know about: protons, neutrons, and electrons. These subatomic particles are what make up all the atoms in the universe. Protons and neutrons are found in the nucleus, and can sometimes be called nucleons, and electrons are found in electron shells, sometimes referred to as energy levels. Protons have a positive charge, electrons have a negative charge, and neutrons are neutral. The neutrons behave like glue inside the nucleus, and they hold the positively charged protons in place. They stop the like charges from repelling. The positive charge of the protons is what holds the electrons in place. In terms of the mass of each of these subatomic particles, we use relative mass to compare the masses to each other, as their actual masses are so small. You can see the majority of the mass of an atom comes from the nucleons. This heavy mass, coupled with the small size of the nucleus, makes the nucleus extremely dense compared to the rest of the atom, and you need to know all of the numbers on this page. Now that we're more familiar with atoms, we're going to look at what happens when a bunch of the same atom come together. We get what's known as an element. We can see here a piece of lithium metal, which is made up of lithium atoms, which look like this, and are themselves made up of subatomic particles. We can see all the different elements, and therefore all the different types of atoms on the periodic table. The letters that represent the chemical are called the chemical symbol, and always start with a capital letter. If there are any subsequent letters in the same symbol, they will be lowercase. We need to be able to use this periodic table. The key things to look out for at this stage are the atomic number, sometimes called the proton number, and the mass number. The atomic number is what differentiates atoms of one element from the atoms of another element, and is based on how many protons an atom has. Each subsequent atom has one more proton than the previous one, and the proton number can never change, because if it did, then the type of atom would change. The numbers of electrons and protons in an atom need to be the same, as atoms, by definition, have no charge. The mass number is the total number of neutrons and protons, as all the mass comes from them, as per the previous slide. So we can do a little calculation to work out the number of neutrons by simply subtracting the atomic number from the mass number. As mentioned in the previous slide, the proton number can never change, as that will change the type of atom we have. However, the number of neutrons can change. All this will affect is the mass number. If the number of neutrons does change, then the mass number will change as well. However, as we have the same number of protons, the atom will still be the same type of atom, it will just be slightly heavier or lighter. This is what we call an isotope, a different form of the same element which has the same number of protons but different number of neutrons. We can see an example here. We have two atoms with 6 protons each, therefore they must both be carbon atoms. However, one has an extra neutron, therefore it weighs slightly more. Both of these are isotopes of carbon, commonly referred to as carbon-12 and carbon-13. As there are different isotopes of the same element, which have different mass numbers, we need to come up with an average mass number to put in the periodic table. This average mass number of all the different isotopes of an element is called the relative atomic mass, or AR, as is written here. You have to be able to calculate this. Luckily it's not too difficult and the formula is here. We have to sum up, that's what the capital sigma means, it means sum. We have to sum up the abundance of each isotope multiplied by the mass number of the isotope, and then divide the answer by the sum of the abundances of all the isotopes. Abundance is often given as a percentage, but not always. This is how we would use the formula in question. Magnesium has 3 different isotopes with a mass of 24, which is by far the most common one, as it has a 79% abundance. We have magnesium 25 and magnesium 26. We'd expect the relative atomic mass to be very close to 24, as 79% of magnesium atoms are of the Mg24 variety. We do the calculation as follows, multiplying mass number by abundance for every isotope and summing the answers, then dividing by the total abundance. We then see the average mass of a magnesium atom, taking into account all of its isotopes, is 24.3. Now we're focusing on compounds, substances formed from two or more elements. The atoms of those elements have to be held together by chemical bonds, and these are in fixed proportions. A chemical bond means that there has been some transfer of electrons, but we'll get into that in another video. Just like every definition in this video, you have to learn it word for word. Here, we can see the arrangement of atoms in an element, which has only one type of atom, and we can see how atoms are arranged in a compound and in a mixture. Again, the key difference is that the atoms of differing elements in a compound are held together by chemical bonds, whereas in a mixture there are no chemical bonds present. So these chemical bonds can either be ionic bonds, which occur between metals or non-metals, or they can be covalent bonds, which occur between non-metals only. Ionic compounds form these giant structures called lattices, whereas covalent compounds are often made of molecules. A molecule is just two or more atoms bonded together. Again, we'll look at all this stuff in much more detail when we look at bonding in another video. So just like we have symbols to represent elements, we can combine these symbols to represent compounds. CO2 is the symbol for carbon dioxide and shows that there are two oxygen atoms for every carbon atom in a single molecule of carbon dioxide. Finally, with regards to compounds, we need to know that the properties of a compound are totally different to the individual properties of the constituent elements that make it up. We'll revisit this on the next slide. The last thing we'll look at in this video are mixtures. Mixtures are made up of separate substances which are not held together by chemical bonds and can therefore be separated by physical methods only. You can imagine putting a bunch of sand into a cup of sugar and mixing it with a spoon. You do not have a brand new compound. No chemical bonds have been made, but you now have a mixture of two different things. A more familiar example may be that of air. Air is a mixture of different gases that you could separate out if you wanted to, but they all just exist together but not held together by chemical bonds. It makes sense then that the properties of a mixture are a mixture of the properties of the constituent parts. There's an interesting example that makes this all clear here. You can pause this video or you can look at it at the end of the video, the difference between a compound of iron and sulfur and a mixture of iron and sulfur. Finally, as mixtures are not held together by chemical bonds, you can separate them out using physical methods. These include everything listed here, so chromatography, filtration, evaporation, crystallization, and the two types of distillation. Watch the next video to hear about this in more detail. If you guys learned anything from this video or appreciated at all the effort that went into making it, please subscribe, comment, like, and share. Peace.